Good morning. I can't get enough of this geometric algebra. It's so much fun. You got to try it. Uh, let's take a simple the system of linear equations: ax plus by equals c, dx plus cy equals g. Now we can write these like you would in linear algebra by saying x times this column vector ad plus y times this column vector be equals these two constants cg. All right. So I'm going to write this as vector v1, this is vector v2, and this is vector v3. All right. So I'm going to have an equation like this: x times v1 plus y times v2 equals v3. This is standard linear algebra stuff. Now, remember the rules of using the wedge, the product. A wedge b is equal to minus b wedge a, and a wedge a, any vector wedged with itself, is equal to 0. These are the two rules that we need, okay? So I want to take this equation and I want to isolate x. So I want to get rid of y. Well, I'm going to wedge it from the right. Now, it matters in geometric algebra which direction you're coming from, okay? Because of this. One's a negative of the other. So I'm going to go this direction with v2. So I get this equation, right? So I wedged from the right with v2. So this becomes 0 because of this rule. And we just are left with this. Now here's something that'll blow your mind. These are called bivectors, and you can divide them. Yes, you can divide them, unlike vectors, which you cannot. So you just divide both sides by v1 wedge v2, and you get this answer. So here is the solution x for those equations. Now let's write the equation down again. Now we want to isolate y. Well, we do exactly the same thing, but this time we're going to wedge it from this side, from the left, with v1. We pull the scalar out. We get this goes to 0. We're left with that. And we divide both sides by v1 wedge v2. I love this. And you get y. We've got both x and y. That is the solution to those equations. So let's do a specific example, okay? So I made up two equations, these two, and let's go look at them, make sure they got a solution, first of all. Okay, so here's the first equation that we made up. X plus 2y equals 3. And another equation, y minus x minus y equals 4. And you see they have a solution. Right there it is. All right. Now, you obviously don't need to do geometric algebra to solve something this simple. You can probably do it in your head. But I'm just making a demonstration here, okay? Because it's fun. All right, now let's go back to our dot. Okay, so here's the two equations. Now we just pick off of here our vectors. So v1 is 1, 1. v2 is 2 minus 1. And v3 is 3, 4, okay? So we're representing these in Cartesian, the coordinates with these orthonormal bases, the vectors, all right? So we go back up there and we get our equations. X is equal to v3 wedge v2 divided by v1 wedge v2. So we put in v3 and v2 and v1 and v2, okay? So here's the way this works. E1 wedge E1 is 0, E2 wedge E2 is 0, so you just don't have to worry about them. So this is 3 times 1 is a negative 3 E1 wedge E2, and 4 times 2 is 8 E2 wedge E1, but I want to swap those so I have the same wedge, right? So when I swap it, it becomes a negative. So it's a negative 3 minus a plus a minus 8, which is a negative 11 E1 wedge E2. Do the same thing on the bottom. So this is 1. It gives a negative 1. This gives 2. We swap them, E1 for E2. It becomes a negative, so we get a negative 3. The negatives cancel. We get X is 11 thirds. I'm just going to leave it like that. Do the same thing for Y, exactly the same procedure, and you swap these two, so you get a negative, and you get a negative 1/3. So let's go see if that's the answer. Okay, so here's our two linear equation. That is the solution. And we're hoping that is going to be, there it is. That is 11 divided by 3, and that is a negative 1/3. That's the solution to these two equations by using geometric algebra and the wedge the product. Isn't that just so much fun? You can't stand it. All right, see you later.